Okay, so here we've got the results table from the titration we've just done. We've got the rough titration here, and then we did 2 further titrations to ensure that we got 2 concordant results within 0.2 of each other. The first thing we need to do, as you can see here, is to calculate the mean. So we would do 24.6, add 24.8, divide them by 2, and that comes out at 24.7 centimetre cubed. Now we know 2 pieces of information about the sodium hydroxide. We know the volume and we know the concentration we used. Therefore, using this equation here, we can actually calculate the number of moles. So the moles of sodium hydroxide is 25, but it's got to be in decimetre cubed, so you're going to have to divide by 1,000 and times that by the concentration. When you put that into your calculator, that comes out at 0.0025 moles. Now if you look at the balanced equation here, we can see that the molar ratio is a 1-to-1 between the acid and the hydroxide. So because we know this number of moles that we've just calculated for sodium hydroxide is also the number of moles of the acid. So now we actually know 2 pieces of information about the acid. We know what the volume is, how much we added. We know the number of moles, and so we can use this same equation that we used up here, rearrange it to find out what the concentration is. So concentration is moles divided by volume. We know the moles was 0.0025. The volume in decimetre cubed was 0.0247. And so when you do that calculation, it comes out at 0.10 moles per decimetre cubed. An alternative way of doing this is by writing 2 shopping lists, and you fill in what you know. So we knew that the volume of this was 24.7 centimetre cubed. We knew the volume of this was 25 centimetre cubed. We knew the concentration of this was 0.1 moles per decimetre cubed. So we needed to find this. We can calculate that in the way I've just shown you, which we knew was 0.0025 moles. From the 1-to-1 relationship, that also shows us that this is 0.0025 moles. This was the big question that we wanted to answer. That was the whole point of doing the titration for an unknown concentration. We've now got 2 pieces of information from there, so we can find out what the concentration is. This way just helps you to set out what it is you already know and what it is you need to find out in using the mole formulas.